Okay, so number 2 is a question about titration, and they are talking about titration, the phosphoric acid solution of whose volume is this much is completely neutralized by this volume of that molar concentration of sodium hydroxide. Okay. So now the titration is essentially your titrant is OH minus. So OH minus, OH minus. So concept here is OH minus is meeting with an H plus from the acid. They will be completely become like that. So they'll be consumed until this is fully gone. So that's the first information. The second information is when people say phosphoric acid, it is their chemical structure is H3PO4. So what that means is this one generate 3H plus and PO4 minus 3 minus. So they can generate equivalent up to generating 3 protons. Okay, so we are going to essentially convert the concentration. So let's say the 3117 milliliter, 1000 milliliter is 1 liter. Their concentration 1 liter in 4.0 mole. And let me just say this is same as OH, because this is complete hydrolysis, H plus and OH minus. And so the concentration of NaOH, sodium hydroxide, is same as hydroxyanion concentration. So this is a number of moles from that. And then one thing that we know from this the one-to-one correspondence, so I can say 1 OH is same as a 1 H plus, so that's a one-to-one correspondence. So now 1 mole, right? OH mole, and then 1 mole H plus, and then 1 mole of H3O4, H3PO4, PO4, and so then I have to change this to 3 moles. So that's a unit conversion factor that goes in. So therefore, if you multiply this one, this is a 3117, 1 over 1000, 4, 1, 1 over 3. And that will lead me to calculating as a 0.04156 mole H3PO4. That's a phosphoric acid number of moles at the titration point. And then now this is a concentration of H3PO4. I don't know why I'm keep on skipping this. H3PO4, which is H3PO4 is a mole of H3PO4. I think I'm going to hurry mode. H3PO4 volume solution, right? Volume of the solution. And how many volumes you are talking about here? That's a 25 milliliters. So it's a 0.025 liter, and the number of moles is 0.04156 mole of phosphoric acid, and this will lead me to 1.662 moles of H3PO4 concentration. Okay. So that's the answer. And one thing that to notice here is all the numbers are given with 4 significant figures. So we can carry up to 4 significant figures throughout when we calculate those numbers. Okay? So this one is also, I understand that there is 4 significant figures. If somebody wants to be exact, 0.2500 liters, so that we can retain 4 significant figures. Now, when we find this the titration condition, where essentially at titration, obviously the concentration of, or not the concentration, the moles of H plus is same as mole of H plus, the same as mole of OH minus, right? Some proton has a multi-protic acid, and this is an example of phosphoric acid. Understand the chemical structures. They generate 3 of them, so that this is a 1 to 3 correspondence when you convert the concentration H plus to phosphoric acid. Okay, thank you for your attention. The answer for concentration of phosphoric acid is, this is the answer.